Good morning, students. We were doing the lesson electricity. In that lesson, we have studied about the resistance, how they are connected in series, what will be the formula when the resistances, number of resistances are connected in series, then the total resistance will become R is equal to R1 plus R2 plus R3 and so on. Let it be any number of resistance. If I want to calculate the total number of total resistance when number of resistances are connected in series, so I can calculate by using the formula R is equal to R1 plus R2 plus R3. This is the combinations of the resistance when three resistances are connected in series. And student, when the resistances are connected in series, it means the total resistance will increase. Once the total resistance will increase, what it impacts, what will be the effect of this? Once the resistance is high, definitely the current will be less, because current and the resistance both are reciprocal to each other. Already I have explained to you. Once the two quantities they are reciprocal, it means one quantity it is increasing, another quantity it is decreasing. Now resistance is more, definitely the current will be less. So second formula which we have studied, that when the resistances they are connected in parallel, what will be the total resistance? Now the resistance, say three resistances are connected in parallel, then the formula will be 1 by R1 plus 1 by R2 plus 1 by R3. It means this is in parallel, this is in series. Now students, if I take the examples, say three resistances R1, R2 and R3, they are connected in parallel. Parallel combination, already I explained, say these are the three resistances, students, 1, 2 and 3. In series combination, I'll show you like this, 1, 2 and 3. Three resistances, they are connected in series, correct? The formula is R is equal to R1 plus R2 plus R3. Now all the parallel combinations, say resistance R1, this is R2 and third one is R3. Now this will be the pattern of the three resistance R1, R2, R3. They are in the parallel combinations. Now what will be the total resistance when they are connected in parallel? So the total resistance will be less than the given resistance of the individual resistance. Say R1 by R1 plus 1 by R2 plus 1 by R3. Now 1 by R. Now if I calculate the total resistance when three resistances are connected in parallel, it means my total resistance will reduce. Now students, so if the resistance is less, definitely the current will be more. If I want to increase the value of current, now the pattern should be, the resistance pattern should be in parallel, because all the resistance are connected in parallel, only then I can increase the value of current. Clear, student? So these were the two formulas which we had studied during our previous lecture. Clear, student? Formula number 1, formula number 2. So the R is equal to R1 plus R2 plus R3. And here is a 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear, student? Now NCERT questions, the question number, now I read it out the 14 questions one by one, which are on the page number 216. Now students, first question I'll read it out. First question says, judge the equivalent resistance when the followings are connected in parallel, 1 ohm and 10 raised to power 6 ohm. Now students, now as per question, the given questions statement, the value of the resistance is 1 ohm and 10 raised to power 6 ohm. Now two resistance, Now, students, now we have to think, because as per the formula 1 by R1 plus 1 by R2 plus 1 by R3, now two resistances, the value of one resistance is 1 ohm, and second, the resistance value is 10 raised power, that's a 10 raised power 6 ohm. Now, student, if these two resistances are connected in parallel, the total combinations of these two resistances, the resultant will be lesser than 1 ohm. The total resistance will be less than 1 ohm, because I'll use the formula 1 by 1 divided by 1 by 10 raised power 6. Then if I give the LCM, it means this total value will be lesser than 1 ohm. Clear, students? Now, part 2, what it says, the 1 ohm, then 10 raised to power 3 ohm, and 10 raised to power 6 ohm. What it says, 1 ohm, and 10 raised to power 3 ohm, and third one is a 10 raised to power 6 ohm. Now, he is saying that three resistance, 1 ohm, 10 raised to power 3, 10 raised to power 6 ohm. They are connected in parallel. What will be the total combinations? What will be the total results? Total resistance when three resistance 1 ohm, 10 raised to power 3 ohm, and 10 raised to power 6 ohm are connected in parallel. In this case also, students, the total resistance will be less than 1 ohm, because in the denominator, if I use the formula 1 by 1 plus 1 divided by 10 raised to power 3 plus 1 divided by 10 raised to power 6. If I would calculate all these three values now in the denominators, now students, if the value is more in the denominator, definitely the result will be less. The result will be less than 1 ohm. Is it clear, student? Now, three resistance, 1 ohm, 10 raised to power 3 ohm, and 10 raised to power 6 ohm. They are connected in parallel. What will be my result? That total resistance will be, the total resistance, it will be less than 1 ohm. Clear, student? This was your numerical number 1, and we have solved the first part as well as the second part. All the two parts, the answer of both the part, the resistance, the net resistance is lesser than, it will be less than 1 ohm. Clear, students? Now we'll switch on to the question number 2, page number 216. So I'll read it out the statement of question number 2. Now what it says, students, the question number 2. Question number 2 says, the statement is like this: an electric lamp of 100 ohm. Clear? He is given the value of that lamp, the resistance is 100 ohm, correct? Then he is given the value of toaster. The resistance of the toasters, that it is a 50 ohm. Clear? Then he is given the third appliance also. It is a water filter of resistance. It is a 500 ohm, because different appliances. Now, student, what are the, because say in this case, toaster is there and the water filter is there, and it is electric lamp. All are having different appliances, are having different resistance value. Clear? Are connected in parallel. Again, what it says, all these three appliances, the resistance of all the three appliances, they are connected in parallel. Now, student, so as it is, you know that when the resistances, they are connected, let it be any value. Let it be any value, 50 ohm, 100 ohm, 500 ohm. So irrespective of the value, but when you will apply the formula, 1 by R1 is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The net resistance will be less, because in the denominator, once the value is increasing, definitely the net result will also decrease. Clear, students? So by applying the formula, first I'll write down the first appliance is lamp. The resistance of the lamp is given. Say lamp resistance is given as the 100 ohm. It is the first case. Now second appliance, what he has given, the second toaster, it is a 50 ohm. Third, what it says, third check, what he is given, the water filter water filter आएगा WN, it is given as a 500 ohm. Now three appliances, 100 ohm, 50 ohm, and 500 ohm. Now all the three resistances, they are connected again in parallel. We'll apply the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we'll put all the three values of R1, R2, and R3 in this formula. What we will get? 1 by 100 plus 1 by 50 plus 1 by 500. Clear, student? If I take the LCM 100, 50, and 500, so my LCM will be 500 in this case. Clear, students? Very simple. Now 100, 500, if I divide 5, here 10, and here 1. 5 plus 10 plus 1, so it will be 16. It will be 16 by 500. So now what we have obtained, 1 by R is equal to 16 divided by 500. If I just rewrite it, it will be R is equal to 500 divided by 16. Because 1 by R, now it will become as R. Then in the right hand side also, it will become as a 500 divided by 16. So after calculating the value of, after dividing the 500 by 16, we will get, it will be 31.25 ohm. Now the net resistance, when the three resistances are connected of value 100 ohm, 50 ohm, 500 ohm, they are connected in parallel. The net resistance we have seen, it will be 31.25. Now students, now what is our, what should be our observations after solving this numerical? So we have seen the minimum resistance was given by these electrical three appliances, 100 ohm, 50 ohm, 500. Means the second one, which was as a, say, toaster, say 50 ohm, was given as a resistance. So what we have obtained the value 31.25, which is also less than the 50 ohm. Clear hai? Now it is very much clear that when the resistance, number of resistances, let it be any value, if they are connected in parallel, our result will be lesser than of the that of the individual resistance. Means एक resistance जिसकी वैल्यू मिनिमम होगी, उससे भी हमारी वैल्यू जो नेट रेजिस्टेंस आएगा उसकी वैल्यू कम आएगी, और रेजिस्टेंस की वैल्यू कम आएगी, डेफिनेटली स्टूडेंट, then value of the current will be more in this case. Now student, what it says, he is saying further to that numerical, we have to calculate the value of current. Now students, the value of R is calculated. Now if I want to calculate the value of current, I will apply the formula of Ohm's law. The Ohm's law formula says V is equal to IR. Now there are three variables, student, in this case, V, IR. If out of the three variables, two are known to you, if two are known to you, very well, we can calculate the third one. Now here, V is given. Now student, V is given. In this case, he is given. Now value V is given as a 220 volt. V is given 220 volt because the supply which comes to our house, it is also 220 to 230 volt. Clear, students? Now value of V is given and R is given. We have calculated 31.25. Now we want to calculate the value of current. If I put the value of V and R in this formula, so I can calculate the value of I by using the formula. Now students, the value of I will be V divided by R. The value of V is 200. Now, if I put the value of R, it is a 31.25, which we have calculated after using the formula of the parallel combinations of three resistances. It is 31.25. Now, if I divide 200 by 31.25, so the value of current will be 7.04 ampere. Whenever student you are calculating any value in this, say, let it be current potential difference, you must write with the unit. SI unit must be written in that, because the current, the SI unit of current is ampere. Clear, students? So the my value will be for that the resistance is 31.25, first answer, and second answer, now the value of current should be, it will be 7.024 ampere. Clear, student? I think this numerical number 2 very much I have explained in details. There should not be any doubt. If you want to note down, please you can note down. Then further we will switch on to the numerical number 3. Please note down if you want to note down. Clear, students? Very simple numerical step. If you follow this step one by one, then definitely there should not be any chance for any mistakes. Okay, there will not be any chance for committing any mistakes, because you know the formula. Only simply you have to put the value, and little bit calculation is there. That calculation part you have to see, because there should not be any mistake while calculating the values for obtaining the result. Clear, students? So I think this numerical is clear to you. Now we'll switch on to the numerical number 3, question number 3 of your NCERT on page number 216. Clear, students? I read out the statement of question number 3. Clear, students? Question number 3 says, what it says? What are the advantages of connecting the electric devices in parallel with the battery instead of connected in the series? Very, very important student question. Already I have discussed when I was taking the lesson in detail during previous lecture also, because these questions, why the connection should be parallel, are more advantageous than the in the series. Because a very, very important question for your competitive exam, NTSC, and even though including your JEE means, and all these type of questions are being asked, because they are on the, because you have to apply the means law, and where the some of the its concept is also there. So after applying it, then what it means, you have to think in details. Now, student, what could be the observations, or what could be the advantages if we are connecting all these? Okay, we are using the parallel connections. Now, first should be number 1 advantages. First advantage, student, say I'll take the example, live example. In your domestic circuit in your house, when you are doing the say electrical connections in your house, for whenever you are constructing the house, that time the electricians or the mechanic is making all the connections. Now, students, this is in parallel combination. The reason, if the supply of the one appliance is failures, अगर स्टूडेंट अगर एक appliances की supply failures हो जाती है, then other appliances will not get affected. Means अगर हम चाहते हैं कि स्टूडेंट की हमारे मान लो पूरे घर में मान लो एक रूम की सप्लाई अगर मान लो ठीक नहीं है या काम नहीं कर रही, तो ऐसा नहीं हो सकता कि दूसरे रूम में भी सप्लाई ना, because if the connection is in parallel. So my first, what we have concluded, so if the electrical, that the appliances stop working due to the any of the defect, कोई भी defect हो सकता है, so all the other appliances will keep on working. First advantage है student. ठीक है, first advantage क्या है? If one appliances is failure, then other appliances will not stop working. Will not stop working. दूसरे काम करते रहेंगे, दूसरे appliances काम करते रहेंगे. Second advantage क्या हो सकती है students? Then each has own switch. अगर मान लो आपके रूम के अंदर स्टूडेंट्स अगर ट्यूब लाइट्स भी है और फैन भी है और उसके बाद में एसी भी है और भी बहुत सारी चीजें हैं इलेक्ट्रिकल अप्लायंसेस, आप चाहते हैं कि yes, you don't want tube lights because daytime light is sufficient, so you don't want the tube light should be on. So it means that different switch will be there. You can switch off the tube light and you can just switch on the fan, because whatever requirements are there, you can use that switch. So different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can write down. So it can, different switch can be, it has own switch. I can w then it has on switch. It has on switch. भाई फैन का है तो फैन का अलग स्विच होगा, बल्ब का तो अलग स्विच होगा, एसी का अलग स्विच होगा। ऐसा नहीं है कि अगर एक ही स्विच से, अगर मान लो आपने एक स्विच को ऑन कर दिया, ऐसा नहीं होना चाहिए कि आपके कमरे की सारी लाइट्स ऑन हो जाएं, सारे फैन ऑन हो जाएं, एसी भी ऑन हो जाए और भी जो इलेक्ट्रिकल अप्लायंसेस है वो भी ऑन हो जाए। नो, ऐसा होगा तो बहुत सारी इलेक्ट्रिसिटी विल बी वेस्टेड ना, बिकॉज आपको चाहिए तो बाकी चीजें नहीं चाहिए ना। यू वांट ओनली वन थिंग, दैट यू वांट ओनली वन फैन शुड बी रन। सो उसका अलग से स्विच होगा स्टूडेंट। अगर आपको नहीं चाहिए तो आप उसको ऑफ कर सकते हैं। मींस डिफरेंट अप्लायंसेस विल हैव द डिफरेंट स्विचेस। सेकंड पॉइंट क्लियर है स्टूडेंट। नाउ थर्ड पॉइंट क्या है कि द सम ऑफ द वोल्टेज, नाउ इट इन दिस केस द सेम वोल्टेज 220 वोल्ट, ईच अप्लायंसेस विल गेट 220 वोल्ट। कि सभी को जो 220 वोल्ट ही मिलेगा, all three appliances will get the same voltage। ऐसा नहीं है कि फैन को तो कम मिल रही है और उसके बाद में अगर लाइट है, ट्यूबलाइट है, उसको कम आ रही है वोल्टेज। नो, इन केस ऑफ पैरेलल द वोल्टेज रिमेन सेम। दिस इज द थर्ड एडवांटेज स्टूडेंट। सो फोर्थ एडवांटेज विल बी द ओवरऑल रेजिस्टेंस विल बी लेस। ओवरऑल रेजिस्टेंस इट विल बी less. The overall resistance will be less. इसका क्या मतलब है स्टूडेंट्स? भी ओवरऑल रेजिस्टेंस अगर कम हो जाएगा, रेजिस्टेंस कम होगा तो उससे क्या होगा? हमारा रेजिस्टेंस कम होगा, करंट की वैल्यू इंक्रीज हो जाएगी। एंड स्टूडेंट्स और भी उससे क्या है कि हमारा जो हीट इमिशंस ऑफ हीट इट विल बी लेस। हीट जो इमिट है वो कम हो जाएगी। Clear students? So these are the four advantages why we are using the parallel circuit, that in comparison to the series circuit. Again I repeat all these three, all four the steps. First, all the different in case of that the power supply is failures for one appliances, the other appliance will not stop working. Clear student? Now second is it has on switch. ये भी क्लियर है। थर्ड, the all the appliances will get the same voltage, it is 220 volt. Then fourth one is overall resistance will be lesser than that of the total resistance. Once the resistance value decreases, so lesser heat emissions will be there. So these are the four advantages of why we are using the parallel circuit. Clear student? Very important question student. So what are the advantages of using the parallel circuits? Please. Now we'll switch on to the next question, question number 4. What it says? Question number 4 says, how can the three resistances of 2 ohm, 3 ohm, 6 ohm are connected to give the 4 ohm and 1 ohm? Again student, this type of the numericals are being asked in your exams, CBS, that board exam, and as well as in the competitions also, because they will be giving the different values and even the answer will be given to you. Answer is also here. He has given the answer also, but only we have to show the circuit, or we have to calculate the how the circuit will be there, how the combinations of the three resistance, so that we can obtain this much resistance, the value of this much resistance. Now question, now in case of the value is given to ohm, then 3 ohm, and he is given as a 6 ohm. फर्स्ट केस में स्टूडेंट क्या आना चाहिए? आंसर क्या आना चाहिए? हमारा आंसर बोल रहा है 4 ओम आना चाहिए, और दूसरे केस में कह रहा है वो क्या आना चाहिए? 1 ओम। पहले हमको ये वाला आंसर कैलकुलेट करना है। इन द सेकंड पार्ट वी विल कैलकुलेट 1 ओम, हाउ द कॉम्बिनेशन शुड बी। नाउ स्टूडेंट्स, अगर ये 2 ओम रेजिस्टेंस है और बाकी मेरे पास जो दो रेजिस्टेंस क्यों है, ये 3 ओम है और अगर ये 6 ओम है, अगर मैं इसको ऐसे कॉम्बिनेशन कर दूं, देखिएगा बड़े ध्यान से देखिएगा, कि दो रेजिस्टेंस 3 ओम 6 ओम है, इनको तो मैं पैरेलल में कर दूं, ठीक है, और एक रेजिस्टेंस जो मेरे पास 2 ओम का है, इसको मैं सीरीज में कर दूं, तो देखते हैं कि मेरा रिजल्ट क्या आता है। If the two resistances 3 ohm and 6 ohm both are connected in parallel, so what will be the result of resultant will be 1/3 plus 1/6, LCM is 6, 2 plus 1 is equal to 3/6 is equal to 1/r. Now 1/r is equal to 3/6 is 1/2, and R is equal to 2 ohm. Now student, means all the, now this 3 ohm and 6 ohm in place of both the resistance. If I will this have the parallel combination of 3 ohm and 6 ohm, so my net resistance will be 2 ohm. Now student, 2 ohm is this and 3 ohm and 6 ohm connection are parallel. Now it is also 2 ohm. So my now two resistance, this is 2 ohm and 2 ohm, they are connected in series. What will be the my net resistance? It will be 4 ohm. Means 2 ohm and 2 ohm both are connected in series. My net resistance will be 4 ohm. Clear, students? So we have obtained, we have reached to the first answer, that is the 4 ohm. Is it clear? So the combination will be like this: one resistance, then two resistances, 3 ohm and 6 ohm, they are in parallel. Clear here? Now for obtaining the second result, that is the 1 ohm, how this resistance should be connected. So the net resistance should be 1 ohm. For how we will have the combinations of all the three resistors, that also we will see in this. Now students, our given values are 2 ohm, 3 ohm and 6 ohm. If I put all the three resistances, 2 ohm, now students, this is 2 ohm, this is 3 ohm and this is 6 ohm. If I put all the three resistances in parallel, so I'll see the what will be the my net resistance, 1 by R1 plus 1 by R2 plus 1 by R3. So I'll put the value 1 by 2 plus 1 by 3 plus 1 by 6. Clear here? Now student, LCM is a 6. Now 3 plus 2 plus 1 is equal to 6 by 6. Clear here? 3 plus 2 plus 1, it is 6. LCM is 6. 6 by 6, it is a 1. Now student, 1 by R is equal to 1 by 1 and R is equal to 1 ohm. This is my required result or required answer. So it means what we have concluded, that in first case, one resistance should be like this in series and another two resistances should be like this. Clear है? दो resistance तो parallel में और एक resistance series में, first case में, और second वाले case में all these resistances like 2 ohm, 3 ohm and this is 6 ohm. All the three resistances, if they are connected in parallel, 2 ohm, 3 ohm, 6 ohm, then my net resistance will be, it will be 1 ohm. Clear, student? Now we have reached to the answer second also. Clear here? Now student, we'll switch on to the question number 5. Question number 5, what it says. If the concept is clear, student, then there should not be any problem for solving this type of the questions or numericals. Clear here? I read the statement of question number 5 of your NCERT on page number 216. Now, what is the highest? आगे क्या बोलता है? The lowest, then total resistance that can be secured by the combinations. Now, students, of the 4 resistances. Now, he is given the value 4 ohm, 8 ohm, 12 ohm and 24 ohm. Clear, students? Question number 5. Now, value क्या दिया हुआ है student? 4 ohm दिया हुआ है. Clear है? 4 ohm दिया हुआ है. 4 ohm और दूसरा वैल्यू दिया हुआ है स्टूडेंट 8 ओम और तीसरा वैल्यू दिया हुआ है 12 ओम और चौथा दिया हुआ है 24 ओम. क्लियर है? नाउ स्टूडेंट्स, इफ द हाईएस्ट वैल्यू कब होगा? हाईएस्ट वैल्यू कब होगा स्टूडेंट्स? एज इट इज यू नो दैट व्हेन ऑल दीस 4 रेजिस्टेंसेस क्या क्या है? 4 ओम, 8 ओम, 12 ओम, 24. 4, 8, 12, 24. When the 4 resistances, they are connected in series by applying the formula R1, that plus R2 plus R3 plus R4, it will be, now formula R is equal to R1, 4 plus 8 plus 12 plus 24. If I will calculate, all this value. So 4 plus 8 plus 12 plus 24. My value will be 48 ohm. So this is the highest when they are connected in series. Your answer of question number 5, the answer of first part, highest resistance is 48 ohms when all the 4 resistances they are connected in series. Correct, students? It should be clear to you. Now, second case, when it will be the lowest. When it will be lowest, when they are connected in, definitely they are connected in parallel. The formula again 1 by R1 plus 1 by R2 like this means 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. If student 4, 8, 24, 8, 12 and 24. Now you want to calculate the total value, we have to take the LCM 24, 6 plus 3 plus 2 plus 1. 6 plus 3, 9, 9 plus 2, it is 11, 11 plus 1, it is 12. So 12 by 24, 12 1 is 12, 12 2 is 24. Means 1 by R is equal to 1 by R is equal to 1 by 2, and R is equal to 2 ohm. R is equal to 2 ohm. Now, student, what we have calculated and what we have obtained in case of if all the 4 resistance, 4 resistance, 4 ohm, 8 ohm, 12 ohm, 24 ohm, they are connected in series. We have seen if they are connected in series, that they will be having the highest value, that is 48 ohm. Clear? First answer. Now, second answer, their value will be minimum when all the 4 resistance, 4 ohm, 12 ohm, 24 ohm, their first part is 48 ohm and the answer of second part is 2 ohm. So for if you will have the comparison, एक तरफ तो 48 ohm है स्टूडेंट और एक तरफ 2 ohm है, तो देखा जाए तो 48 और 2 का बहुत बड़ा डिफरेंस है. 48 is the highest value and 2 is the minimum value. Clear, students? So these were your NCERT questions of page number 216. Now today, student, we will continue with the very important topic, heating effect of electric current. Now, students, this is a very important topic which I am going to take now. So, students, as it is the name of the topic, heating effect of electric current, and each and every word it will be clear to you. Heating effect of electric current. Electric. What did it say, students? जैसा कि कंसेप्ट का नाम है, हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट क्या है? भाई, करंट के पास होने से जितने भी हमारे आप देखते हैं इन अवर सराउंडिंग्स एंड डेली वी ऑब्जर्व आल्सो कि जितने भी हमारे आसपास में इलेक्ट्रिकल अप्लायंसेस हैं, लेट इट बी माइक्रो ओवन, लेट इट बी बल्ब, लेट इट बी मोबाइल आल्सो, लेट इट बी मिक्सर ग्राइंडर, रेफ्रिजरेटर, एयर कंडीशनर्स एंड सो ऑन. So many electrical appliances which run by the use of electricity, all are known as electrical appliances. जब वो electrical appliances run करेंगे, उनको run करने के लिए supply चाहिए, and they will emit light, they will emit heat, they will emit the heat energy. With थोड़ी देर के बाद, जितनी देर तक हम उसको यूज करेंगे, थोड़ी देर के बाद क्या हो जाता है, वो गर्म हो जाते हैं. ऐसा क्यों? और ये क्या, कैसे कैलकुलेट करें हम? भाई, हीट कब कम होगी, हीट कब ज्यादा हो जाएगी, किससे? इसी बेस पे स्टूडेंट्स हमारी बहुत सारी चीजें बनी हुई हैं. से nowadays the winter season is there, you must have seen that's the heaters and all, electric heaters, they are being used. Okay, so they are giving out heat to से मिल रहा है, radiations. So इस कंसेप्ट को हम स्टडी करेंगे स्टूडेंट्स. नाउ इसी लॉ को साइंटिस्ट जूल ने एक्सप्लेन किया था, तो इसीलिए हम इसको बोल देते हैं जूल्स लॉ ऑफ हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट, इसको तो उसी का नाम आगे ऐड कर दिया। तो होता क्या है स्टूडेंट्स, वी नो द डेफिनेशंस ऑफ, नाउ स्टूडेंट्स है क्या कि देखिए यहाँ पे पावर पावर को क्या होता है, पावर इज इक्वल टू V into I, ये बात क्लियर है स्टूडेंट्स। और we also know that V is equal to W by Q, क्लियर है, ये बात क्लियर है स्टूडेंट्स कि potential difference is the amount of work done in bringing the unit positive charge from one point to